Alrighty then, guys and girls, we're back with another installment of the fun-filled, action-packed, non-flipped Algebra 2 classroom videos with me, Coach Goo, and we're starting in Unit 3 now. Unit 3 is all about solving absolute value equations and inequalities. Today, notes number 1, we're focusing on solving absolute value equations. So first, quick little review. Let's go ahead and take a little bit a few seconds, 30 seconds or so to find, and you probably don't even need 30 seconds, to find the answer to these: absolute value of 4, absolute value of -4, and absolute value of 0. Alright, so the absolute value, remember, we just take what's inside the absolute value bars and it just becomes positive. The result of whatever's inside becomes positive. So absolute value of 4 is 4, absolute value of -4 is 4, and absolute value of 0 is just 0. Alright though, but what is the definition of absolute value? Have we even talked about what actually is the definition? We know how to find it, but do we know how to define it? The definition of absolute value is how far a number is from 0. Because you see, with this definition, there's no positive, there's no negative, it's just how far a number is from 0. It's always a positive number when you're talking about how far away something is. So now check this out though, big star right here, importante. If the absolute value of x equals 4, what could x be? Take a second and give me your answers. X could be 4, of course, right? But x could also be -4. Oh my goodness. Wow, is that what you said? Amazing. X could also be -4, right? Because if I take the absolute value of either of these numbers, it becomes 4. All right, so check this out. Absolute value equations. What is absolute value used for in real life anyways? It's used for situations where positive and negative don't matter. For example, distance. You know, when you ask somebody, hey, how far is Dallas from Houston? You don't say, oh, it's -200 whatever miles. You know what I mean? And then like when you say, oh, how far is Austin from Houston? Let's say it's 200 miles. Austin from Houston is 200 miles. And then you say, how far is Houston from Austin? You don't say -200. Distance is always positive. It's absolute value. Like you can see this example right here. We take the first place that we're talking about, like Houston, subtract the second place, Austin, and then the absolute value of that would be the distance because we're always talking about a positive number. All right, so now let's formulate some absolute value equations. Watch this. Write an equation that represents all real numbers that are 30 units away from 18. So how would we write this? Take a second and try to write an equation that would represent all real numbers that are 30 units away from 18. All right, so it would end up actually looking like this. Absolute value of x minus 18 equals 30. X minus 18 equals 30. Now, why is that? Because look, if I had a number line like this, and we're talking about units away from 18, so 18 is my center, so here's 18. And I'm talking about 30 units away, so this space, right, I'm so bad at drawing squigglies. This is 30 units. This is 30 units. What could x be? If I went 30 units to the left in the negative direction, I would have -12. And then if I went 30 units the opposite direction over here, positive, I would have +48. Now, those are my possible x values. How can I check this? Watch this. If I put -12 in for x, -12 minus 18, what is supposed to equal 30, right? Well, what's -12 minus 18? That's -30. An absolute value of -30 is 30. We did it, boys. And then also let's check the other number, 48. If we put in 48, subtract 18, that's supposed to equal 30. Oh, wait, this is my check mark. 48 minus 18 is 30, and the absolute value of 30 equals 30. So check, boom, we did it. So that's how you're going to write it. All right, looking at the next one, write an equation to determine how much is in a bank account if there's a balance of 400 and then a transaction worth $36 is made. So the transaction is worth $36, so let's put equals 36, all right? And then we know we're gonna have absolute value. And our other number, we're gonna subtract from x. So x minus $400. And then we'd find our answer here. And you could see that same thing, we'd have a number line like this. Boom. Start at 400 because the transaction doesn't say if I added money in or if I spent money. It just says transaction. So we could be going 36 in this direction, making more money, or we could be going 36 in the negative direction, losing $36. But regardless, that make my X values 436 and 364. And if we plug these numbers in for X, you could see that we would have 36 as our answer. Now, what makes this an absolute value problem, the second part of the question, is because it just says transaction. It doesn't say positive or negative. It doesn't matter if we're going positive or negative direction. It's just a transaction. All right, now getting into the good stuff, we're actually going to see how to solve an absolute value equation. Oh my goodness. We have 3 different ways. 3, count them. 1, 2, 3 different ways to solve an absolute value equation. Now, first method right here is the number line method, okay? This is a fan favorite. A lot of people like the number line method. If you look here on the left in this box, it tells you that the absolute value of x minus b is going to equal k. The distance between x and b is k. That's pretty much what that's saying. And then you got a little graphic right here. It tells you exactly where to put all your numbers on the timeline. So let's take a look at our equation. We're trying to solve absolute value of x minus 2 equals 3. Now looking at our equation here inside the box, we can see b is right there. So we're subtracting b. So what would b be in this case? B would be my 2. And what would my k be? Look at this, k is right here. K would be 3. Okay? And then we can see that right here, b is going to be our center. Okay, b is the center. So we are going to put, let me write this out actually, b center. And then k is going to be the distance. So on our number line, we're going to use the number line to actually just draw this out. So the center is going to be at 2. So we can just put 2 wherever we want to. So let's go ahead and put it right. Let's put it right here. 2. Okay. Actually, I'm not going to draw a dot. 2. And then what's the distance? It's 3. So we can move 3 in either direction. So let's just go. Ready? 1, 2, 3. And there's one of my points. What's 3 spaces away from 2 in the positive direction? That's going to be positive 5. And now let's go the other direction. 1, 2, 3 spaces. And what's 3 spaces in the negative direction? That's going to be negative 1. So with this number line, drawing it out like this, we can see that our 2 answers are right here, negative 1 and 5. So x equals negative 1 or x equals 5. Oh my goodness, that's the number line method. All right, next, let's do the graphing method. This is the graphing method. So look, we got the little steps over here. This is the exact same equation. We're going to see if we get the exact same answers. Remember, we had x equals negative 1 and we had x equals positive 5. So let's see if we get the same answers using the graphing method. Spoiler, we are. All right, so it tells you graph the left side, y equals absolute value of x minus 2. You see this x minus 2, that's the left side. So we're going to graph y equals this left side. So absolute value of x minus 2 tells me to move my absolute value parent function over 2 spaces to the right. So it's going to be like this. Transformations, baby. Translation, 2 spaces to the right. All right, then we're going to graph the right side. Okay, and the right side is over here. It's just 3. So we're just going to put y equals 3. It's always y equals whatever side. And y equals 3 is a line that looks, that's at 3. So it's going to be 3 is right here. Boom. Like this. And then the points of intersection, because there could be many points, there could be just one point. Those are solutions. So right here, look at this. Boom. And then right here, boom. What are the x values right here? The x value right here is negative 1. And x value right here is positive 5. So we can see our points, again, x equals 1. And x equals negative 1. And x equals positive 5. Just like we got in our answer above. But this time, we use the graphing method. And then in our final method, you know, I like this one the best because it's just so mathematical. It's the algebraic method, okay? So we're going to solve the exact same problem just to make to show us that all of these methods gives the exact same answer. Now remember, the solution when we tried to find the absolute value of x equals 4, we got x equals positive 4. We got x equals negative 4. So if we want to solve an equation algebraically, all we have to do is set up two equations, one that equals the positive and one that equals the negative. If you're confused about what that means, watch this. Watch me. So we're going to take absolute value of x minus 2 equals 3, right? We're going to remove the absolute value bars, and we're just going to make two equations, one equaling the positive, so like this x minus 2 equals 3, and we're going to make one equaling the negative, x minus 2 equals negative 3. And then we just solve from here. So let's see, plus 2 on each side here, boom, x equals 5. Wow, that's one of my answers. And the next one over here, plus 2, x equals negative 1. Oh my goodness. Oh, my fish is done, guys. Bet you didn't know I was a chef. So for me, the algebraic method is just going to be the quickest way because it's just straight up math right there, right then and there. So let's do some examples then. Example 1, what is the solution of absolute value of 2x minus 1 equals 5? Graph the solution, check your solution. So you might be wondering, what does graph your solution mean? Let's go through this example and you'll find out. So first, let's find the answer. So I'm going to use the algebraic method because it's just the quickest and easiest, and the other ones don't really make sense with this. Well, the graphing does, but there's no graph here. So let's do 2x minus 1 equals positive 5, and then 2x minus 1 equals negative 5. And let's solve. So we're going to add a 1 to both sides, plus 1 plus 1. 2x equals 6. What am I doing? 5 plus 1 is 6. Divided by 2. X equals 3. Okay? So I got one of my answers, x equals 3. And then my other one, let's add 1 to both sides. 2x equals negative 5 plus 1 is negative 4. Divided by 2 to get x by itself, and x equals negative 2. So my two answers are x equals negative 2 and x equals 3. And now by graphing, this is what it means. We're going to start at 0, all right? We just want to graph this. So start at 0 right here. And then we just graph our answer. So negative 2 would be left 2 spaces right here, negative 2, and right 3 spaces, 1, 2, 3. And 3 is right there. That's all it means by graphing, okay? So now we're going to check our solution. And how do we check our solution? We're going to plug our answers back in to this equation and see if it's true or not. So 3, we're going to plug 3 in. So 2 times 3. So 2 times 3, because that was one of our answers, minus 1 equals 5. What's 2 times 3? That's 6 minus 1 equals 5. What's 6 minus 1? That is 5. And does the absolute value of 5 equal 5? Yes, it does. Check. So we checked one of our answers. That answer is correct. Let's check the other one. Now we've got 2 times negative 2 minus 1 equals 5. What is 2 times negative 2? That's negative 4 minus 1 equals 5. What's negative 4 minus 1? That is negative 5 equals 5. And is the absolute value of negative 5 equal to 5? Yes, it is. Boom. Both of our answers work. All right, example number 2. Here we go. Absolute value of 3x plus 2 equals 4. So same thing. 3x plus 2 equals positive 4. And 3x plus 2 equals negative 4. So let's solve. Subtract 2 from both sides. Boom. 3x equals 2. Then divide by 3. And x equals 2 over 3. Now as for the other one, we're going to subtract 2 from both sides. Boom, boom. 3x equals negative 6. Then to get x by itself, we divide by 3. And then x equals negative 6 divided by 3 is negative 2. So my two answers are x equals 2/3 and x equals negative 2. So now let's graph this, okay? So this time I'm going to make this a little different, but we're going to have 0 right here. And then I'm going to break this up into different space. I'm going to break it up a little bit more. So I'm going to put 1 right here and 2 right here. Negative 1 and negative 2. So one of our answers was negative 2, so I'm going to go ahead and put my dot there. Boom. And then 2/3, where's that? That's before the 1. That's 2/3 of the way, so it's going to be about here. And I'm going to label it so everyone knows 2/3. There we go. And so now let's check our answers, check your solution. We're going to take -2 and put that back into the equation up here and see if it works. So absolute value of 3 times -2 plus 2 equals 4. What's 3 times -2? That's -6 plus 2 equals 4. What's -6 plus 2? That's -4. And is the absolute value of -4 equal to 4? Yes, it is. We did it. And let's check the other one now. Absolute value of 3 times 2 over 3 plus 2 equals 4. So 3 times 2 over 3, I'm going to do it over here on the side. 3 over 1 times 2 over 3 equals 6 over 3, which is the same thing as 2. So now I've got 2 plus 2 equals 4. 2 plus 2 is 4. And is the absolute value of 4 equal to 4? Yes, it is. So we did it. We checked our answers, and we're done. Number 3. This is the most hairy looking one. Okay, you see that it's asking for the solution for 3 times the absolute value of x plus 2 minus 1 equals 8. All the other ones we worked with, we had absolute value on one side and then the numbers on the other side. This one we can see it's all jumbled up. So what we want to do is get the absolute value by itself on one side. So let's go ahead and fix that up then. Let's add a 1 to both sides. Boom. So now we're going to have 3 times the absolute value of x plus 2 equals, what's 8 plus 1? That's 9. And then to get rid of this 3 right here that's being multiplied, we're going to divide by 3 on both sides. That's gone. And now I just have absolute value of x plus 2 equals 9 divided by 3 is 3. So the new equation that I'm working with is right here. Absolute value of x plus 2 equals 3. So let's set up our equations then. X plus 2 equals 3, and x plus 2 equals -3. Let's solve. So let's subtract 2 from both sides. Boom, boom. X equals 1. Okay. And then let's subtract 2 from both sides over here. And x equals -5. There we go. And so let's graph it. We got, let's see, 0, -1, -2, -3, -4, -5. So one of my points will be right here. And then 1's right here. So my other point will be right there. Boom. There we go. And let's just check our answers now. So we're going to take a 1 and put it into the equation. Put it into this equation right here. Absolute value of x plus 2 equals 3. So absolute value of 1 plus 2 equals 3. What's 1 plus 2? That's just 3. So absolute value of 3 equals 3. Is that true? Yes, it is. We've checked that one. Let's check the other one. Absolute value of -5, because that was my other solution right here, plus 2 equals 3. What is -5 plus 2? That's -3. And is the absolute value of -3 equal to 3? Yes, it is. There it is, guys. So remember the 4 steps. We isolate the absolute value. We get the absolute value by itself on one side. Then we write 2 equations, one equaling the positive, one equaling the negative. Then we solve and we check our answers. And that's it, guys. So I'll see you guys in the next one. Peace!